Hello and welcome back to Steam It with Steve. Today we're going to keep going on with our Pythagorean exploration. We're going to look into the world whether or not a right angled triangle is a right angled triangle. Now what I mean by that is if we know all three sides inside of this triangle, we should be able to work out if it is a right angled triangle simply by using Pythagoras' theorem. So let's jump on in. So if you're given a right angle in this triangle, we're going to have a look and see by putting the values in, does it sort of match up? So one of the interesting things that I've just found out by doing a little bit of research is that ancient Babylonians actually used right angled triangles to build their structures. So you might have heard of the Tower of Babylon, which is meant to be the greatest tower in the world, or the ancient world. And yeah, basically they used right angled triangles to help build these impressive structures that went on and on and on. Now there's a cool little video there that you guys can have a look. I'll put the link down below. But it goes through and proves that it was 1,000 years before Pythagoras existed that these clay tablet existed that showed the Pythagoras' rule, which is kind of cool. And this is way before any technology existed. Now, the controversial part with that is whether or not Pythagoras found that ancient knowledge from someone else and then sort of claimed it as his own. So some of the lesson intentions that we want to go through, we want to prove whether or not triangles are right angled. We then want to explore the difference between surd and exact value again, just a little recap on that, and then tackle some of these mind-bending problems. So if we're given a triangle with A and B, just as a little recap, we should be able to now know which rule to use. So if we're given those two different values, we should be able to find the hypotenuse by using the traditional method for Pythagoras, which is h squared is equal to a squared plus b squared. Similarly, if we're given another triangle with h and b, we can then find that mystery side by using to find the leg, so one of the smallest sides, by doing a squared is equal to h squared minus b squared. Cool. So to be right or not to be right, that is the question. So to prove this, whether or not it's a right angled triangle, it's really simple. You just literally have to see whether or not a squared plus b squared equals the hypotenuse squared. And if that's true, you've got a right angled triangle. So to do that, if we're given our good old 6, 8, 10 triangle and we want to prove it, we just literally put the values in. So if we go 6 squared plus 8 squared and that equals 10 squared, and it does, so 100 does equal 100, we're all good. Similarly, if we try and do another one with 12, 4, and 9, if we go 9 squared plus 4 squared is equals 12 squared, it doesn't equal, so therefore it's not a right angle triangle. So this is pretty much the same as the triplet example we gave before, but this time around you might have irrational numbers sort of thrown in the mix, which can work. So our first challenge is to have a go through these. Just pause the video and see whether or not you can work out if these triangles are right angle triangles or not. Awesome. So what you should have found with the first one, that is a right angle triangle if you put through the rules. This one is definitely not a right angle triangle. Normally isosceles triangles don't work out because of the 1, 1 and the 2, because 1 squared plus 1 squared equals 2, and then the hypotenuse would be the square root of 2. Similarly down here, 2, 3, 5, that was not a right angle triangle. This one here was a right angle triangle. The 6, 8, 5 was not a right angle triangle. And lastly, the 9, 40, and 41 was a right angle triangle. Cool. Now just a quick little recap on what surds are. Hopefully you remember this. A surd is a square root number that does not make an integer. So for example, the square root of 2, hopefully you remember the example where we put that in, and it was 1.142135 blah, 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 and that went on and on and on. And that's why it's called an irrational number. It never has a set pattern within inside of it. Whereas if we do the square root of 4, that's just equal to 2. So that is a rational number. So the square root of 2 is what we call a surd, but the square root of 4 is not a surd. So that's very important, that terminology. Sometimes when you do a bit of problem solving, it's actually better to keep it in its surd form or its exact value, rather than doing its approximate value by trying to solve it. So just pause the video, have a go, see if you can do these ones. Cool. So the first one that you found there was a right angle triangle. The 5, 13, 5, 12, 13 was a right angle. The 6, 7, 13 was not a right angle. The 3, 7, 7.5 was not a right angle. The 4, 8 square root of 80 was a right angle. The 8, 24, 26 was not a right angle. The 8 square root of 36, which is just 6, 10 is a right angle. And the 11, 12, 17 was not a right angle. And then the 9, 14, 15 was also not a right angle. So hopefully you've been able to go through those and that's sort of making sense for you. So there is a little worksheet for you guys to go through. The link is up on the OneNote. And yeah, that's it pretty much for me. So to be able to prove whether or not a triangle is a right angle, very, very simple. Literally just put the values of the triangle in, so the three sides, into the Pythagoras theorem. The trick here is to work out which one's the biggest side. So the biggest side will always go as the h squared, and the other two sides that are left over goes there. So that's it from me. Hopefully you've enjoyed that. And if you did like it, please give a like and subscribe, as it does help with the YouTube algorithm. That's it for me. Thanks again. See you next time on STEAM with Steve. Adios.